Welcome to this video. Today we're going to look at network corridor optimization through the use of degree of saturation limits in transit. This network shows 3 junctions along a main arterial road corridor. I will now switch on one of the many overlays available within the network diagram. In this case, I am showing the min max Q output. The orange bars stretch all the way back to the upstream end of the lanes on some of the interior traffic streams and have a black tip at the end. The fact that orange covers the entire lane indicates that the min max Q reaches at least as far back as the next junction, and the black tip indicates that the orange overlay actually exceeds the length of the lane. I will also switch on one of the text sets. These have the ability to customize what data is shown on top of the traffic streams in 3 locations. In this case, I will simply choose the existing standard set, as this conveniently shows the degree of saturation in the middle position of each traffic stream. Both of the overlays indicate that the main road is oversaturated and blocking back from junction to junction. Fortunately, Transit offers the ability to set a degree of saturation limit to any traffic stream. When optimized, Transit will then hunt for a set of timings to keep the degree of saturation within desired limits. Shortly, I will add some limits along the corridors to see if I can improve the performance of that corridor. This, of course, is likely to be at the expense of the side roads. Before changing the model data, however, I wish to capture a route along the network so that I can obtain journey time results for anyone travelling the length of the corridor. Holding down the Control key, I can use the left mouse click to select each traffic stream from left to right along the corridor, and right click to add these to a collection. One, 2, 3, 4. Right click, add to collection, give it an ID, and my collection has been saved in the file. A collection is simply a subset of items of your network and can be populated with traffic streams, controller streams, and pedestrian crossings. You can, of course, manually set up the components of your collection using the data outline and data editor, but it's often easier to use the select tool in the diagram, as I've just demonstrated. A route is a special collection where the traffic streams are contiguous, i.e. adjoining and in the right order from upstream to downstream. When a route is detected by Transit, it will produce a route journey time, in addition to other results. This is a really useful result, as it can be used to compare with the on-street observations you may have, or with results from other models you may end up using. This is where the route has been identified, and I could open up results. You may notice it's not on here, so what I need to do is go into Data, Model Results and Options, and switch on journey time results. Not all results by default are switched on within Transit. A lot of them are switched off, so you're not overwhelmed with the amount of output you might have in the program and might not need all of it. In this case, I need journey time results, so I'll switch that one on. If I now go back to the collection, you should then now see the fact that I've actually got there should be a new tab appear on here called Journey Times. And the very bottom item on there is the one that is only available when a route has been detected. I'll run the file now to populate that with some data. Full optimization of the network just occurred, and you can see the route journey time here as approximately 190 seconds on here. I'm going to also padlock this once to the journey times, twice to the particular collection, and then a third time we'll freeze the screen, and you'll see why later on. I've deliberately digressed somewhat, so I better get back to the matter in hand. the setting up of my degree of saturation limits. If I go back to the diagram and just double click on one of the traffic streams I want to set a limit to, I now need to go into the Modelling tab, and then from the sub-tab into the Weights and Penalties. On here, you'll see degree of saturation penalties near the bottom of this screen. I will now tick that. You'll notice it's been pre-populated, I did this earlier on to save time, with a degree of saturation limit of 85%, excess degree of saturation penalty of £10,000. Each limit has to have a cost associated with it, in this case 10,000, so that when the limit is breached, the cost applies to the network performance index. This is how the optimizer is influenced to provide solutions where these breaches are reduced. Remembering, the optimization process is trying to bring down the performance index number all the time. Note that I said reduce and not remove, as the limits will tend to be breached to some extent, simply because if they were not, the extra penalty cost would be zero and would then not influence the optimizer. This concept is important to understand. The fact that to achieve a particular outcome in terms of degree of saturation, you need to set the limit slightly more strictly than the outcome you wish to achieve. As an example, if you wish your corridor to have a degree of saturation value no more than 90%, then you may need to set your excess degree of saturation limits to 85% or lower to achieve that. Also note that penalties have to be particularly high, as they only apply when the limit is breached, and high values will ensure that it's kept to a minimum. So I'll just finish off adding in my other three limits, applying it to the internal traffic streams on the main corridor. Just double check they're all there. And I'll run the optimizer again. Upon running the transit optimization, you can clearly see the degree of saturation is reduced and the min-max queues shortened with the new timings. I will now go back to the journey time screen here. Remember, I froze it earlier. I can now double click on this to bring up the new data so I can compare it directly with the old one. You can see how the 190 seconds has now dropped to about 168 seconds down here. So there has definitely been an improvement, at least from location 1 on the left hand side of the network along to the far end on the right hand side. Please note, however, that I use one single local matrix to allocate the traffic to this network. More typically, you might use one local matrix per junction, but I have in fact, given the network's relatively small, I've chosen to use one across the whole network. The one advantage of doing that is if I open up the local matrix, you'll find that I've actually got an alternative way to get access to journey time information, because all local matrices have that available to them. So within the journey time tab on the ODE matrix, I in fact have the journey time information in all directions, from every location to every other location. Anyone that is 0 is purely an indication that there's no vehicles making that manoeuvre, hence there's no value to present. That's all. This brings me to the end of my presentation. I hope that you now have an understanding of how to apply degree of saturation limits and to get journey time information across your network. I'm Jim Binning, and that concludes my presentation. Thank you for watching.